Okay, so the last video stopped recording randomly. I think this is where I left off. So I have x squared minus 4, okay? This is sort of a bad example because it says you should have linear factors, which would mean you'd be to x to the first power. X squared plus 4 does not factor. I think when they made the review, they just changed some numbers and didn't realize it wasn't a great example. If it was x squared minus 4, we could factor that, because that would be a difference of 2 squares. But this does not factor, so x squared plus 4 is a factor. Don't forget, though, that I still had this over here, that x equaled negative 4. I have to put that in somehow, and you just do that by setting it equal to 0, and that you can just add 4 to each side. And once it's equal to 0, it's a factor. So x squared plus 4 times x plus 4 gives you that original polynomial we ended up with. Okay? I'm moving on, so if you need to, please pause the video. Now, number 19 says graph 3 plus x over x plus 1. There's two things it asks for, the vertical asymptote and the horizontal asymptote. The vertical asymptote is the easiest in my opinion. That is the one where you just take what's on the bottom and set it equal to 0, because it can't equal 1. Or, I'm sorry, it can't equal 0. So if I solve this, I would have x equals, not negative 1. Miss Dunn's been doing this all day. I'm a little tired. X equals positive 1. So if x is 1, that's when I'd get 0 on the bottom where it's undefined. So we know my graph is not going to have a point at x equals 1. Okay. We also have to look at the the horizontal asymptotes. Now there's 3 possibilities here. Okay. For the horizontal asymptote, you're always comparing the degree of the top to the bottom. And there's only 3 situations. Number 1, they're the same. If they have the same degree, all you have to do is take, or let's rephrase this. All you have to do is you'll have a horizontal asymptote at the ratio of the LCs, leading coefficients. The second scenario is that the top is bigger than the bottom in terms of degree. When that's the case, when your top is bigger than the bottom, there is no horizontal asymptote. Okay, and the last one, when your bottom, let's try that again. When your top is smaller than your bottom. When your top is smaller than your bottom, your horizontal asymptote is going to be at y equals 0. So let me separate these for you. Now, in our case, the degree of the top is 1 because that's the highest degree on an exponent, and the degree at the bottom is also 1. So when I look at this, they're the same. The horizontal asymptote at the ratio of the leading coefficients. Well, the leading coefficients are going to be the numbers in front of those variables, so 1 and 1. So my horizontal asymptote is going to be at y equals 1 over 1, or simply 1. So it's not going to touch here either. At this point, I'm just going to sort of plug some x values in to see where my graph is. We know it's going to curve somewhere. I'm going to draw these in as an example. I don't know where they go yet. It might curve like this and like this, or like this and like this. It could go like this and like this. We don't really know. So I'm going to erase what's on the bottom. So if you need to write this down, pause the video. Oops. Well, that did not work now, did it? Here we go. I'm going to erase this, so if you need to, rewind at this point, and then you can come back. Okay? So, I'm just going to pick some x values. And you can see the blue line, I'm just going to rewrite it in here for us, is at x equals 1. So I'm going to pick some on the right of it and to the left of it. So I'm going to plug in 2. So if x is 2, I'd have 3 plus 2 over 2 minus 1, which is 5 over 1. So I'd have the 0.25. Okay, so you can see it's up here. Maybe I'll pick one further on down. Maybe I'll let x be 8. I don't know. I'm just making up numbers. I'm sorry. That's not correct. It says 3 plus x, so 3 plus 8 over x, which is 8 minus 1, gives me 11 over 7, which is just a tad bit bigger than 1. So when I'm at 8, I'm just barely over 1. So you can see, and this does not want me to draw dots, so bear with me. I don't know that I'm going to be able to do this. There we go. I know that's at 2, but let's just pretend it's barely above it. So I know my graph is going to go in here somewhere, and it's going to somehow curve like this. It's not going to be perfect, okay? Now I have to figure out what's going to the left of my vertical my vertical asymptote. Okay, so I'm going to pick to the left. Let's try 0. So if I let x be 0, I get 3 plus 0 over 0 minus 1, 3 over negative 1, which is negative 3. So at 0, I'm at negative 3. Again, I know that's not perfect. Let's try negative 4. When x is negative 4, I get 3 plus negative 4 over negative 4 minus 1. I get negative 1 over negative 5. Okay, so I get 1/5. That's a positive 1/5, which is just above 0. So when I plugged in negative 4, because remember that's what I plugged in for x here. So this really should say y equals, I'm a little tired, I've been doing these all day long. This was when x was negative 4. I get 1/5, so just barely above 0. Okay, and that's about all I need. I can tell you that my graph is going to look something like this. It does not have to be perfect. The graphs won't be that close where you're going to have to make a judgment call. Okay, I am going to erase this and move on to number 20. So, state the vertical asymptotes of the graph of f of x equals 7 over x plus 5. So the vertical asymptotes are the ones where I'm just looking at the bottom. Okay, so all I'm interested in is x plus 5. So, and I don't want it to be 0. X plus 5 equals 0. I'm going to have a vertical asymptote where x equals negative 5. I am moving on, so again, pause it if you need to write this down. The cotangent of 15. We learned about cotangent in terms of a right triangle. I'm not sure that we learned to put this in the calculator. Number one, you need to make sure that your calculator is in degrees. You go to mode and make sure degree is highlighted. We know the cotangent is the reciprocal of tangent. So what you're going to put in your calculator is 1 over the tangent of 15 degrees. That's how you, if it was, well, let me put that in and then I'll tell you how to do the rest. 1 over the tangent of 15 equals 3.73. If it's the cosecant in your calculator, remember the cosecant is the reciprocal of the sine, so it would be 1 over the sine. If it's the secant is the reciprocal of cosine, so it would be 1 over cosine. Okay? 24. We have learned part of this, but not in its entirety. So I'm going to kind of go over it and do the part that we know. So it says if the cosine of theta equals 0.9872 and your angle is between 0 and 90 degrees, find the value of theta. So when I'm looking for the angle, that means I'm going to use the inverse. So I'm going to take the cosine inverse, which in our calculators is second cosine of 0.9872. Okay, so let me put that in my calculator. So I'm going to second cosine, and again, making sure that your calculator is in degrees. You don't need to do it multiple times, just the first time you touch the calculator for the day, or the batteries lose power. 9.18 is what I get. Okay. We have learned part of 25, but not enough yet that I would expect you to know it. So this would be one of the ones on the final that I would say, let's skip. Not skip, but you'd guess, and if you get it correct, good for you. If not, it's going to be curved. Okay, 26. Find x for the triangle below. So if I look at my angle, Okay, and I label opposite, so opposite, hypotenuse, and adjacent. Okay, and just remember our little saying, SOHCAHTOA. I want to know the adjacent and I know the opposite, so which one uses O and A is tangent. You set it up, the tangent of your angle, which is 37 degrees, equals your opposite, which is 7.2 over x. Okay, to solve for x, I got to get it out of the fraction, so I'm going to multiply each side by x. Sorry, when I get close to the edge, it likes to go to the next page. Okay, so I have x times the tangent of 37 equals just 7.2 because the x's cancel. Then I divide through by the tangent of 37, and I get x equals, I'm going to put 7.2 divided by the tangent of 37, and you get x equals 9.55. We have not looked at 27. 28 you can do simply in your calculator. That would be typing in the cosine parentheses. The inverse tangent, remember that's second tangent of negative 1/3. Okay, so if I'm finding the cosine of the tangent inverse, I don't know why that flipped, sorry, of negative 1/3, it ends up giving you 0.94. There's more to it than that. We'll learn about it second semester, but for now that's actually 0.95, sorry. That's about as good as we're going to get for right now. We did not learn 29. I'm going to stop this video and continue on in a minute.